Welcome to lesson 20, graphing trigonometric functions. So our main goal in this lesson is to determine the base graphs, like what just sine x, cosine x, tangent x, etc., what their graphs look like, and then get some vocabulary associated with those graphs and work on shifting them, just like we've shifted all of the other functions that we've done so far in this class. So we're going to start with the graph of sine and cosine. They're very similar graphs, so they kind of go together. Now, I have a table of values here for you, and as you can see, I also have the graph of sine because I wanted a nice, pretty picture of it. When we go to graph it by hand, it's a little bit harder, but I just want to go through and find some sine values for the first rotation. So we're just going to graph somewhere between 0 and 2 pi, okay? So I want you to take a minute to fill in what is the sine of 0, what is the sine of pi over 4, etc. And you'll notice that I've actually done 0, pi over 2 pi, 3 pi over 2, and 2 pi. So what you would need to fill those in, right, if we're kind of practicing from our last lesson, would be the unit circle. Those are the 4 angles where I'm actually going to use the unit circle. So I'm just going to fill in the coordinates of those 4 points. And remember, sine is the y coordinate. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. And the sine of 3 pi over 2 is negative 1. So I can go ahead and fill those all in. 0, 1, 0, negative 1. Oh, and then when I ended up at 2 pi, I came all the way back around, and I'll have the same value as 0 since it's the same angle. And you can kind of see that if we were to go around again, so I got to 2 pi, and then if I was going to go pi over 2 more, which would be what, 5 pi over 2, I would just start the cycle over again. So these values are going to repeat in this pattern every 2 pi. And you can see where they are located on my graph. I have this 0, 0 here. I have pi over 2, 1 here, pi back to 0, 3 pi over 2 down here at negative 1, and then 2 pi is back at 0. So you can see those 5 points that I've just placed, and then you can see that it's actually going to start that over again. Back up to 1, back to 0. It's going to continue this pattern in the next 2 pi, the next rotation. So all of the other angles that I put on here are all angles with pi over 4 as its reference angle. First quadrant, second quadrant, third quadrant, fourth quadrant. So we know that that will be positive in the first and second quadrant, negative in the third and fourth quadrants because of all students take calculus. And then I just need to look at my pi over 4 triangle, which we spent some time talking about in the last lesson, and think of what my sine is. So my sine would be 1 over root 2 or root 2 over 2. In order to graph that, you probably would want some sort of decimal approximation. It's around 0.7. So pi over 4, which would be halfway between 0 and pi over 2, would be around 0.7. So I'm looking at roughly this point here. And now I'm just going to fill in these values with either the positive or the negative same sign, right? Because this sign will be the same with all of the reference angles being pi over 4. It's just going to be positive or negative depending on its final quadrant. So then you'll see that I'm basically looking at these points right here. So from my rudimentary sine chart or XY table, I have these points that I've dotted out on my curve. And when we connect them, we see they make this nice wave-like motion. It starts at 0, 0. It peaks up here at 1, goes back down to 0, bottoms out, I guess, at negative 1 and back to 0. And then it's just going to repeat. So we also know these values will repeat every 2 pi in both directions, this way and this way, because it's either going around one more time or going around this way one more time. So it repeats this pattern over the given interval. Okay. So this is the graph of sine that you're going to want to remember. And in my head, I'm going to draw this. I sort of remember what I call like the 5 points of interest. And this is just for one period. So obviously it continues, right? But if I was just graphing this one period between 0 and 2 pi, my 5 points of interest would be the starting point, that top of the hill, back to the middle, bottom of the valley, back to the middle. So knowing that it starts sort of at that 0, 0, it peaks up there at 1, goes back down to 0, lowers down -1, and then ends back at 0 again. And I'll put arrows here to indicate it keeps going. So that happens between 0 and 2 pi, the middle being pi, and each one of these being sort of those halfway points in between. So those 5 points are going to be the points that we will translate when we start moving these up, down, left, right, etc. Okay. So when you go to memorize or this base graph, you don't want to think of it in terms of, oh, I have to make an X, Y table. You want to think of it in terms of these 5 points, starting at 0 for sine, going up first to 1, back to 0, down to -1, back to 0. That creates one cycle of the graph of sine. Okay. And by the way, we call a cycle the period. The period is the length it takes for one complete cycle. Sort of, oops, that's supposed to say cycle. And for this particular graph, that would be 2 pi. All right, looking at a couple other facts that we can kind of note from this graph, its domain would be all reals. There's no breaks, gaps, jumps, holes, asymptotes. But what about the range? Are we getting every possible y value we could out? Certainly not. We have a top and we have a bottom, and we hit everything in between, but the y values for this graph are only between -1 and 1. The x-intercepts are happening here at 0, pi, 2 pi, 3 pi, -pi. So the way we can write that is x equals k pi, and then k is any integer. Integers are whole numbers, positive, negative, and 0. So those are what integers are. And amplitude, this is a new word that we haven't used yet. And amplitude, I'm going to kind of draw it in. Actually, let me use a different color. I'll use the green here. This is the amplitude right here. And what it's defined to be is half the distance between the maximum and the minimum y values. So the maximum y value is 1, the minimum y value is -1, and so half of that distance. So you could also see this right here as an amplitude. So let's write down what it is, what it stands for. It's basically half the distance from lowest to highest point. Since this graph is so symmetrical, the amplitude in this case for trig functions anyways, will basically be the distance from the middle of the graph to the top or the bottom. Not all graphs are symmetrical like that, so the amplitude does not always get defined this way, but for the trig functions we're doing, it would be. So you can see in this case, our amplitude is 1, but there is a formula for it. You're not really going to need this formula, but it would be 1/2 the highest point minus the lowest point, and then you would do an absolute value around that. So this being the highest y value, and this one being the lowest. So that formula becomes more relevant if you were doing this for a different kind of function that didn't necessarily have the symmetry that this one does. But basically, we can just look at how far up or down from the middle or the x-axis it has gone to do amplitude for sine. Same thing will be applicable to cosine. So we're going to do a table of values for cosine as well. Why don't you go ahead and pause the video and fill in this table of values. Again, I see the graph. I know what it's going to look like, but this is good practice for you to use what you need to use. You see I have those angles that land on the axes again for the unit circle, and same pi over 4. So go ahead and fill that table of values. Okay, how did it go? I used the unit circle, this time the x coordinate for these 4, I guess 5 angles. And then the cosine of pi over 4 is the same as the sine, only it's positive in the first and the fourth quadrants and negative in the second and the third. So that now gave us a very similar looking graph. But this time, instead of starting sine, if you remember, started down here at 0, 0, and then at pi over 2, it went up back to 0. Remember that I kind of said this is how you want to remember it. That's what sine did. The difference is that cosine starts up here at 0, 1, and then goes to 0 next, down to its -1, back to 0, and then it finishes its cycle, if you count its cycles starting at 0, still at 2 pi, back up here at the top where it started. So once again, if I'm looking at my 5 points of interest, they start off being the same x values, 0, pi over 2 pi, 3 pi over 2, and 2 pi. But the big difference between sine and cosine is sine started here in the middle, 0, 0, and then went up. Cosine starts at the top, 0, 1, and then goes back down to the middle. So that's kind of the way you could distinguish between the two and hopefully remember them pretty easily. All right, doing the same observations, our domain and range have not changed. They're the same as they were for sine. It's essentially the same graph, it's just shifted. Sine would have started here, so this graph is just shifted like pi over 2 to the left. The period is the same. It's still 2 pi. It takes it that long to do one complete cycle. This time the x-intercepts are at pi over 2, 3 pi over 2, 5 pi over 2. So again, one way to write that would be x equals k pi over 2, but k is not any integer anymore because it's happening at 1, 3, 5, -1, -3, -5. So we're going to say k is any odd integer, and its amplitude is still 1. So these are the base graphs for sine and cosine, and these are what we need to know what the shape is. We need to know how they're different, sine starting at 0, 0, cosine starting at 0, 1. And in the next video, what we're going to do is start translating these graphs up, down, left, right, etc.